really okay. So for question 1 is more about theory and you need to discuss. Okay, so make sure you don't leave any blank. Okay, try to answer as you could. Okay, because maybe the question 1 will help you to obtain a good mark. Okay, at least ada something like contribution to the marks. Okay, for question 2 is more on multiple fractions. Okay, so make sure you know well about, because this will relate with the multiple vectors. Okay, so this is the highest marks for final assessment. Okay, question number 2, and question 3 followed by what do you call it, non-isothermal reactor. Okay, so that one, make sure you do the tutorial, okay, and try to understand the lecture notes, as well as try to go through some of the examples in the textbooks. Okay, maybe it will help you for the assignment. Okay, so for this question, okay, so actually your MTA, there is one question only. Okay, it's just that the one question divided into 2 parts, okay, different parts. Okay, so make sure you look at the here. Okay, for this one is for A and another one is B for B. Okay, so for A, all right, so it's addition of what do you call it, ethylene oxide concentration. Okay, this is the equation. All right, so it asks you to explain your answer clearly using the fundamental knowledge of reaction kinetics. Okay, means that you have to not only you just say that either it will increase or decrease, but you need to have some explanation. Okay, why that phenomenon occurs. Okay, so for example, for number 1, addition of ethylene oxide, and also before that you have to read first. Macam mana I nak hilangkan ini? Alright, so it said that this is a liquid phase, alright, and this is a second order reactions for A, and 0 order for B. Okay, so the question, the first one is, okay, so you just do it as negative RE is equal to KCA CB. Okay, so this is 2 and this one is 0. Okay, it means that it is KCA squared. Alright, so the first one, addition of ethylene oxide concentration. Okay, is it give any changes to the initial rate of reactions? Okay, so you can say it will increase the rate of reactions. Okay, so how does it increase? Actually, when we increase the concentration, okay, of the A, alright, what do you call it? It will make the reaction faster. Okay, because of what? There is a number of molecules. Okay, number of molecules with energy that has a greater ataupun equal than the EA lah. Okay, so this will increase the initial rate of reaction. Okay, so when we increase the molecules, okay, with minimum energy, okay, it will increase the R0. Okay, as long benda apa yang saya baca, this is from the answer scheme. Okay, but let's say if your what do you call it, answer yelah not exactly 100% like mine, but still relevant, I still give mark. Okay, don't worry. Okay, alright, so for number 2 is increase of reactor volume. Does it increase the initial rate of reaction? Okay, so when we increase the volume, actually, alright, the R0 decrease. Okay, because of what? Okay, this is a constant volume batch. Okay, so constant volume batch, it will relate with C is equal to moles over with the volume. Alright, so if you can see, if V increase here, alright, definitely C will decrease. Okay, so this is the reason lah, because and then C will relate to the R naught. Okay, so you decrease the C, R naught will decrease. Okay, so make sure, that's why you have to understand apa some of the what do you call it, of the equation, alright. Apa explanation behind the equation. Okay, this must be reason. Okay, so you boleh manipulate from here lah. Okay, and then number 3, okay, increase of the reactor temperature. Okay, of course it will increase the R naught. Okay, so the minimum energy, alright, required to proceed the reaction, for a reaction, okay, is called activation energy. Alright, so usually activation energy ni dia akan stay the same, okay, with increasing temperature. Okay, tapi kalau disebabkan there is a temperature, okay, so the kinetic energy caused by the absorbed heat, alright, dia akan cause a greater proportion of the reactant lah. Alright, so dia akan cause a collision between the molecules. Molecules increase. Okay, so bila dia increase, of course dia akan increase the initial rate. Okay, this one answer boleh, another one acceptable kalau you kata T dia tak ada any changes. Okay, sebab ada words isothermal. Okay, so either one boleh. Alright, so understand everyone?
Yes, Doctor.
Okay, alright. So B, same, is related with the ethylene glycol. Okay, jap. Okay, so a homogeneous liquid phase reducible reaction is to be carried out isothermally in a series of reactors. 2 feed stream, alright, given, mixed with the H2O to form a single stream that is equal volumetric flow rate solution. Okay, so actually you have a two feed, alright, and then it become a single here. Okay, so we have a VA naught and then VB naught. Okay, so that's why you have to sum up these 2 feed in order to get V naught. Okay, so V naught is equal to VA naught plus with the VB naught. Okay, so to form a single feed that is equal to a 400 decimeter cube of PFR with 70% will produce 5.3 mole per min ethylene glycol. Okay, so this is what is FC, okay, which is the product. Now we have a plus B is equal to C, alright, whereby the given that the volume of the PFR this ni lah is 400 decimeter cube. Okay, and it stated also, okay, I terus ke number 1 ni, we for CSTR is equal to 500 decimeter cube. Okay, with total conversion of 90%, determine the exit volumetric rate and new production capacity with new vector arrangement. Okay, so now we have a arrangement. Okay, so the first arrangement is this PFR will be upstream, means upstream dia dekat bahagian belakang, downstream dekat bawah dia. Okay, so here we have this one, alright, connect with this PFR, alright, and then we have a CSTR here. Okay, so from here we have, this is the FA1. Okay, of course this is FA naught. Okay, and then we have a FA2, kita tak tahu berapa. Okay, so here V1 dengan V2 dah ada dah, which is this is the V1 and this is the V2. Alright, and X2 here dia dah given, it is 0.9. Okay. So from here, okay, so start with the red law. The red law is equal to KCA CB, okay, whereby CA is equal to CA naught 1 minus X, and then we have CB CA naught 1 minus X. Okay, right, make sure you read carefully. If it's liquid tau, jangan letak itu gas, nanti you akan salah lah semua. Okay, so whereby this one is equals to CA naught 1 minus X squared Okay, and then we have this one is equal to FA naught, okay, V naught, 1 minus X squared. Okay, so from here, you need to start with the first reactor. Okay, don't jump into second. Okay, sebab you ada certain information yang you don't have, so you cannot terus calculate V2. Okay, the V2 will be related with V1. Okay, so start with this one. So PFR, you start with dx over dV. Okay, so equal to negative RA FA naught. Okay, so this is the PFR punya ni lah, design equation. Okay, so just rearrangekan dia in order to get dV. So dV is equal to FA naught. Alright, RA ni replacekan siap-siap dia. Alright, which is KCA naught. Alright, KCA naught 1 minus X1 dx. Okay, so remember dia dekat first reactor. So first reactor kena X1. Okay, so daripada sini you boleh rearrangekan dia, masukkan yang benda ala ni. Okay, sekejap ni lupa letak key. Okay, so masukkan balik, rearrangekan dia, dapatkan dia this one is equal to FA naught. Alright, K FA naught, K V naught kuasa 2 1 minus X1. Okay, sorry, this one kuasa 2, lupa nak tak kuasa 2. Okay, dx. Okay, so this is the information lah yang kita ada. So kita akan integrate this one lah dekat 1 over x1 ni. Alright, so you kena integratekan siap-siap. You akan dapat rearrangekan dia. You akan dapat dalam okay, V is equal to, naikkan V naught. Okay, V naught. Okay, alright, over with the K FA naught. Okay, masa sini you dah cancelkan FA naught lah. Okay, so tinggal you dah integrate ni. So integrate 1 over 1 x1, you akan dapat x1 minus 1. Okay, so from 0.7 to 0, sebab dia kata PFR dia 70% di conversion. Okay, so daripada situ kita tak ada K. Okay, remember ada satu soalan yang tak ingat kat tutorial ke apa, kita naikkan dia K tu ke atas. Okay, sebab nanti kita boleh masukkan dia untuk yang the next step. Okay, so just put it as 400 here. Okay, this one is 400 and this one is I dapat 12. Okay, and then this one you just remain it as it. Okay, you will get KFA naught is equals to 0.84. Alright, so this one actually you will relate dengan some information yang tak ada dekat sini. Okay, dia tak given here in order for you to relate with the V2. Okay, so kalau you start sini, you boleh start terus ke V2. Okay, for example you tak tahu nak relate ni dulu. Okay, tak apa, kalau you start sini, you proceed je dulu dekat V2. Okay, so that you know apa yang nak masukkan nanti kat V2. Okay, so what is V2? V2 is equal to, okay, remember V2 kena minuskan ni dengan ni. Alright, which is FA1 minus with the FA2 over with the, remember dekat second reactor, so should be negative RA2. Okay, so here masukkan balik which is FA1 minus with the FA2. Okay, still the same, this is KCA CB. Okay, here, okay, tak cukup buang. Okay. Ini tadi saya buat. So far ada lagging ke kat my side?
No, tak ada.
Tak ada. Okay. So V2 is equal to FA1, okay, FA2, K FA naught, K V naught yang you keluarkan lah tadi, which is, and then 1 minus X. This one, remember dia dekat second volume. So this one should be X2. Okay. So kuasa dengan 2. Alright. So from here kita tadi tak ada ni kan, kita boleh still guna this one. Alright. So daripada sini actually this adalah sama dengan V equal to FA naught X2 minus with the X1. Okay, keluarkan dia saja. And then we have a KFA0 to V0 2 and then 1 minus X2. Okay, so daripada sini you akan ni what left is we have V2 is equal to V0 squared KFA0, alright, and then 0.9 minus dengan 0.7, remember yang X2 adalah 0.9, 1 minus 0.9. Okay, so KFA0 ni kita boleh guna tadi. Okay, so KF0 is 0.84, alright. So daripada situ masukkan balik. Okay, so this replace with 500 and this one replace with 0.84, and then V0 ni adalah V0 yang baru. Okay, kita tak boleh guna sebab V0 yang tadi you dapat ni adalah V0 dekat sebelah sini. Okay, so V0 sebelah sini adalah yang baru one. Okay, that's why dia kata determine the exit volumetric rate yang keluar sini. Okay, alright. Daripada situ, I letak sini nombor 2 lah, jangan confuse. Okay, so you akan rearrange, you akan dapat 0 equal to 49 decimeter cube over mean. Okay, so this would be the new ni lah new volumetric. Okay, so daripada situ you boleh dapat lah FA1 is equal to FA0 1 minus X1. Okay, so F1 adalah 5.3, dia dah give dah after PFR, dia adalah 5.3. Okay, this one after PFR, this is 5.3 mole per second. Okay, so is equals to FA0 1 minus X1. So FA0 yang baru adalah 17.667 mole per second. Okay, so FA2 boleh kira lah, FA2 is equal to FA0 X2 minus X1. Okay, so daripada sini boleh dapat 3.5334 mole per second. Okay, so make sure bila ada question macam ni, you kena relatekan with each other. Okay, you kena tahu macam mana nak guna information. Okay, so kalau you start sini, you proceed ke next one so that you know apa sebenarnya you boleh relate dengan number 1 ni. Okay, right, so kalau memang kalau you punya jawapan salah, I still give you marks lah untuk jalan. Macam admit juga. Okay, so I will consider lah kalau as long you ada benda ni, I will give you some marks. Okay, so mostly saya tengok macam korang tak alert. This one is CACB, alright, which is dia bukannya KCA, dia KCACB. Okay, dia ada H2O dengan ni. Okay, so this one ada ramai yang silap sini lah, so saya tak pernah saya bagi yang markah dekat area macam ni lah. Okay, sebelum you extend the equation. Okay, so nombor 2 pula, by using the same information of two fixed stream provided in Q1B, replace the PFR with C star as the first factor. Okay, so sekarang ni terbalik pula. You akan dapat CSTR mula-mula, PFR second. Okay, alright, so sekarang ni this is volume 1, this one is volume 2. Okay, and volume dia still tak berubah. Okay, so V1 is 500 decimeter cube and V2 is 400 decimeter cube. Okay, so masukkan balik, this one ada ni lah, A and B. Okay, this one is X1 is equal to 0.7. Alright, X2 is equal to 0.9. Okay, so dia dah bagi dah this one. Okay, so daripada situ guna dulu, tengok pada V1. Okay, so V1 is equal to, remember FO1 X1 dia dekat number 1, so X1 over R negative RA1 dekat number 1. Okay, so V1 is equal to FA0 X1 KCA0, alright, 1 minus X1 kuasa 2. Okay, so this one keluarkan dia. Okay, since dia tak bagi you information CA0, so tak perlu cari, as long kalau dia dah cukup sufficient information lain you boleh replace. Okay, so this one gantikan lah, this is FA0 over V0 squared. Okay, so you will get at the end you rearrange kan, you akan dapat macam ni balik, KFA0 1 over V1, okay, V0 X1 1 minus X1 kuasa 2. Okay, So daripada situ you akan dapat KFA0 is equal to 2.24. Okay, so this information you will use, alright, to get what is the V0 2. Okay, guna balik je sama balik dx over dv is equal to FA0. Okay, make sure this is negative RA2. Okay, dekat rectangle number 2. Okay, now this is consider for the second part PFR. Okay, so daripada situ rearrangekan dia. Okay, you will get V2 is equals to FA0 over with the KFA0, alright, V0 kuasa 2, alright, 0.9 to 0.7, 1 minus x squared dx. Okay, so you akan dapat bila you integrate this one, dia akan jadi x2 1 minus with the x2. Okay, so you kena carilah untuk 0.9 dengan 0.7. Okay, replacekan ni. Alright, naikkan balik dia akan jadi V0 2. Okay, kuasa V0 2. Okay, kuasa 2 sini. And then we have a KFA0. Sini tinggallah KFA0. Okay, so replace semua ni, you akan dapatlah V0 dia berapa. Okay, you akan dapat around 11.59. Nak miss ni lah. Split of second. Okay, so daripada situ repeat balik lah. FA1 is equal to FA0 1 minus x1. Kira balik lah dekat sini. And then FA2 berapa. Okay, so daripada situ you comparekan lah mana satu yang adakah arrangement ni akan memberi difference FA2. So jawapannya ya. Okay, sebab dia akan memberi difference pada flow rate yang ni. Okay, so FA2 ni saya dapat dalam around 3.5334. Okay, so proven that bila kita kenapa jawapan saya pandang? Sekejap saya salah tengok yang tadi. FA2 17. Okay, so I tulis kat sini the new arrangement jawapan dia of in series CSTR and downstream of PFR. Okay, and PFR affect the capacity production of ethylene glycol. Okay, sebab yang ni kita dapat yang ni, so jap. Okay, so inilah jawapannya. Okay, so kalau whatever ada jalan kira, saya bagi markah lah. Okay, walaupun ada answer tu tak tepat ke apa, still you still earn marks there. Okay, so boleh saya proceed ke next cell sebab nak kejar untuk assignment 1 juga.
Boleh.
Okay, alright. So for the second one, okay, we have ethanol, alright, plus with the H2O equal to C2H5OH. Alright, so given second order with respect to C2H4 and zero order with respect to H2O. Alright, so you have to explain your answer clearly using the fundamental knowledge of reaction kinetics. Okay, so the first one is addition of water concentration. Does it affect the initial rate of reaction? Alright, so you tengok balik according to the rate law. Okay, the rate of reaction is directly proportionate to the concentration kan, sebab usually negative RA is equal to K CA CB. Okay, so but in this case we have only K CA sebab CB adalah kosong and this one is 2. Okay, so for a zero order of reaction, sebab dia nak water sekarang adalah zero order. So bila zero order, bila kita increase, alright, increase the H2O, it does not increase the negative RA. Sebab apa? Sebab CB sekarang dah zero order, so tak ada lah. Okay, and then we have a number B. Okay, increase of pressure in the reactor. Okay, disebabkan this is in liquid. Okay, so selalunya kalau kita increase of the pressure, dia does not change the reaction. Okay, dia not change the reaction. Okay, sebab apa? This is liquid is incompressible. Okay, so bila dia compressible, kalau you increasekan dia pun dia tak akan increase kecuali kalau di dalam bentuk gas. Alright, kalau gas we have PV is equal to nRT. Okay, so usually kalau kita increasekan concentration, dia akan ada effect. Sebabnya P is equals to N over V RT, and this one is concentration. Okay, so kalau you increase P, concentration akan increase concentration. Increase pressure, concentration akan increase. So bila concentration increase, R akan increase sebab dia relate dengan ni. Okay, so this is how you tengok lah. Okay, so CA. So kalau you increase ni, baru increase. Okay, so this is applicable kalau untuk gas. Kalau liquid, dia tak ada change lah sebab dia incompressible. Okay, so for addition of catalyst, okay, of course, kalau kita sebab tugas catalyst pun to speed up the reaction. So kalau kita add catalyst, okay, it will increase the RA. Okay, so ini daripada ni lah, you boleh relate dengan activation energy lah. Okay, sebab bila kita add catalyst, alright, it will decrease the EA. Right, so bila EA ni decrease, okay, once EA decrease, alright, K akan increase. Okay, so bila K increase, automatically tengok balik kat sini, RA akan increase. Okay, so make sure same again dekat final exercise my banyak bagi hint dah ni sebab I nak tolong you sebab midterm agak teruk juga tapi luckily 10% sahaja. Okay, so I hope you will cover for assignment 2 dengan sebab assignment 2 dalam 20%, assignment 1 I tak habis lagi mark. Okay, I try lah tengok macam mana. Okay, kalau still macam I kena marking linear ke apa ke, tengok pada performance overall, and 40% for FA. Okay, so make sure benda ni mark up balik lah dekat sini. Okay, so apa yang I cakap dalam kelas, take note. Alright, so usually apa yang cakap tu kadang-kadang ada sikit-sikit hint lah dalam, I tak boleh cakap directly tapi you kena, that's why I nak you fokus lah bila kelas. Okay, so try to get lah untuk 40% nanti untuk final assessment. Okay, so even benda small matter pun, okay, contohnya rate of reaction, okay, benda ni boleh pecahkan lagi 1 over V is equal to what, RA is equal something. Okay, apa signifikan maksud benda ni? Semua you kena tahu teori benda ala-ala ni. Walaupun simple tapi from the equation you kena faham apa maksud equation tu. Okay, itu sangat penting lah. Alright. Okay, so for number second. Okay, so the reaction is to be carried out isothermally in 3 different size mixed flow reactor in series. The first reactor has a volume of 200. Okay, so sekarang V1 dia adalah 200 decimeter cube, and V2 adalah 400, and V3 adalah 600 decimeter cube. Species A and B are fed in separate line to the first MFR. Okay, so benda ni sebenarnya sama dia lebih kurang macam set 1. Cuma saya ubah sikit je kat situ. Okay, sebab I tak nak macam berlari sangat lah. Okay, so the volumetric flow rate to the first MFR is 10 decimeter cube over mean. Okay, so and 10 decimeter cube of B. Okay, so dia dah bagi this is VA naught and this is VB naught. Okay, and this is the mole over decimeter cube, which is this is a CA naught equal to CB naught. Okay, and we have a K here. Alright, so just you need to determine the steady state concentration of A from each reactor. Okay, so just basically lukis lah. We have a tree here. So we have a VA naught and then we have a VB naught. Okay, so we have V1, V2 and this is V3. Okay, so basically V naught yang masuk sini You kena campurkan lah. V0 is equal to VA0 plus with the VB0. Okay. So ni pun macam ada tutorial, kita dah pernah bincangkan yang ada 2 feet ni. So is equals to 20 decimeter cube over minute. Okay, so sekarang ni RA is equal to KCA CB. Okay, and then sekejap I tengok. Okay, sebab dia relate dengan question ni. Alright, so automatically dia dah cakap CB ni adalah kosong kan. So RE is equal to KCA. Okay. So daripada situ you can do it as nak dapatkan tahu dulu pun boleh, nanti pun boleh. Okay. Tapi I suggest you kita tengok dulu apa equation yang terlibat. Okay. So we have a concentration of CA1 here from the first reactor and we have a CA2. Okay, and so on. Okay, so from first reactor, this one you kena buat satu-satu lah from first reactor. Okay, what is concentration of V1? So V1 is equal to FA0 X negative RE1. Okay, bersamaan dengan V0. Okay, is equal to CA0 CA. Okay, over with the KCA. Okay, so from here, remember this is first reactor, so dia akan berkaitan dengan number 1. Okay, so this one is number 1 juga. Okay, so this one kita boleh rearrangekan dia sebab we don't have kita ada information untuk dapatkan tau, simplifykan boleh sebab kita ada V dengan V0. Okay, so from here you can get tau 1 is equals to CA0 CA1 KCA1. Okay, so daripada situ you rearrangekan, you akan dapat CA0 is equal CA1 is equal to CA0 1 plus tau 1K. Okay, so K pun dah diberikan, just masukkan, you akan dapat CA1 is equal to 1.1 mol over decimeter cube. Okay, and then we have a second reactor. Second reactor we need to get CA2 is equal to CA1 1 plus tau 2K. Okay, so here whereby kita dah dapat what is CA1. Okay, so you boleh masukkan sini where CA1 is equal to daripada atas ni lah CA0 1 plus tau 1K. Okay, so sekarang ni kita nak tahu CA2. So CA2 is equals to, okay, masukkan balik what is CA1. Okay, kalau misalnya you macam tak dapat cukup information ni ataupun you tak yakin dengan ni, you boleh derivekan dia balik. So CA2 is equals to, you arrangekan, you akan dapat CA0. Okay, 1 plus tau 2K, right? 1 plus tau 1K. Okay, so masukkan balik equation, you akan dapat this one CA2 is equal to 1.067 mol over decimeter cube. Okay, so CA3 ulang balik macam tadi. Okay, replacekan dia balik. Okay, whereby CA3, okay, I tulis kat sini lah. CA3 is equals to CA2 over with the 1 plus tau 3K. Okay, ini I dapat dari mana? Ini semua daripada sini tau, rearrangekan dia balik. Okay, so try to do it. Okay, so replace je lah. Kalau sini CA0, ini jadi CA2, jadi CA2. So kalau nombor 3, this should be number 3, this one number 3. Okay, so just replace apa yang dah ada, terbalikkan dia lah. Okay, alright, so daripada situ, you will have equals to, okay, relatekan dengan CA1. Okay, so you boleh dapat CA1 is equals to 1 plus tau 2K 1 plus tau 3K. Ni tau So CA1 masukkan balik lah daripada sini pun boleh. Okay, so you will have around 0.649 mol over decimeter cube. Okay, ini jalan kerja saya. So kalau misalnya ada jalan cara lain tapi still reasonable, still have you still can obtain some marks there. Okay, alright. So number 2. Okay, determine the state conversion of A for each reactor. Okay, sekarang ni kita nak dapatkan conversion of A. Alright, untuk setiap reactor. So we have XA1 dengan XA2. Okay. Alright, so dengan XA3. Okay, So start dengan mole balance. Okay, so for mole balance for reactor 1, okay, we have FA0 minus with the FA1 plus dengan RA1, V1 is equal to 0. So V1 is equal to FA0 X1 negative RA1. Okay, so whereby rearrangekan dia, alright, and matikan FA0, okay, you akan dapat X1 is equal to FA0 minus with the FA1, okay, FA0 is equals to V0 over V0. Okay, kembangkan dia sahaja. Keluarkan ni jadi CA0 V0. Okay, jadikan F in term of CV. Alright, so we have this one is equal to CA0 minus CA1. Okay, over with the CA0. Okay, so this one dah cancel. Dapatkan balik daripada sebelum ni punya jawapan. You will get X1 is equal to 20%. Okay, so more balance for reactor 2. Okay, you will have FA1 minus with the FA2 plus with the RA2, V2 is equal to 0. Okay, so rearrangekan balik X2 is equal to FA0 minus with the FA1. Okay, we have FA0. Okay, sebab apa? Sorry ni terus FA2 ya. Sebab FA1 is equal to FA0 1 minus X1. Okay, that's why FA1 kalau you tengok dia dah tak ada. Sebab daripada sini lah. Okay, sebab benda ni sebenarnya fundamental je. Cuma you kena tahu guna. Sini akan bertukar. Remember dekat awal-awal chapter topik 4 tu, saya tunjuk ada link banyak-banyak tu. Lepas tu sini akan bertukar, sini akan bertukar based on the reactor dekat mana. Okay, so daripada situ, okay, this is FA2 ya, FA2. Okay, rearrangekan balik, okay, V0 over V0. Okay, you akan dapat CA0 minus CA2 over CA0. Okay, so masukkan balik equation, you akan dapat X2 equals to 40%, 46.7. Okay, and then more balance for reactor 3. Sama juga, just replacekan dia sajalah, which is FA2 minus with the FA3. Okay, yang in minus with the out. Okay, plus with the RA3, V3 is equal to 0. So X3 is equal to FA0. Okay, FA3 down. Okay, minus with the FA3 over with the FA0. Okay, rearrangekan dia, you akan dapat CA0 minus with the CA3 over with the CA0. Okay, so you akan dapat X3 is equal to 69.6%. Okay, so ini cara saya. So maybe you ada derivation yang berlainan. Okay, that you will get nilai X. Okay. Okay, so number 3 ni, this one dia tak direct. So you kena faham dia soalan. If all of the reactors are in equal size, determine the steady state conversion of A and compare your answer with question 1B2. Okay, so sekarang ni dia kata if all of reactors are equal size, means that V1 akan equals to V2 is equal to V3. Okay, let's say you put it as 200 decimeter cube. Okay, and then of course kalau V sama, okay, and this is dekat liquid. So dekat MFR usually V akan equal to V0. So automatically tau ni akan samalah. So thus tau 1 is equal to tau 2 is equal to tau 3. Okay, let's say you put as 10 minute. Okay, ikut pada you. Sekarang kita just nak analyze. Alright. So for the in a series, okay, remember this is the equation which is equals to 1 over 1 plus tau k quantity n. Okay, sebabkan ada 3, so dia akan jadi 1 minus 1 plus tau k 3. Okay, sebenarnya ni dia boleh keluarkan banyak, tapi disebabkan tau ni sama, so kita boleh equate jadi kuasa 3 sahaja. Okay, so just masukkan nilai tau tu. Okay, let's say it's a 10 minute. Okay, so you akan dapat 0.488. Okay, and then let's say kalau kita increasekan tau dia. Okay, kita nak tengoklah ada tak dia berubah. Alright, ada tak dia berubah pada X. Okay, sebab apa kita play around with tau? Sebab tau ni akan relate with the X. Macam ni K akan sama sahaja nilai, tak berubah. Okay, N pun memang 3. So apa yang you boleh manipulate adalah in term of tau untuk tengokkan conversion dia berbeza ke tak. Alright. So from there try pula tengok ni, kira pula 1 minus dengan same juga apply. Okay, tapi sekarang ni tau dia adalah 20 minit. Okay, so dalam ini awak akan dapat 0.704. Okay, so let's say nak tahu lagi trend dia, kita increasekan pula. Is equals to 30 minit. So XU akan dapat around 0.814. Okay, so kita boleh what we can conclude is equal size has size, okay, has equal size has higher conversion. Okay, ni yang kita boleh simpulkan, and higher T, higher tau, right, has higher conversion. Okay, so inilah jawapan dia. Okay, terpulanglah kalau you nak letak 500 pun boleh. Alright, as long you fixkan ni dan tengoklah pada X ni. Okay, so dia benda ni adalah you kena faham dia punya question lah. So dia kata determine the steady state conversion and compare your answer. So kalau equal size ni means ini dah sama. Cuma yang kita boleh dapat lah X yang berbeza. Okay, so bila kita tengok pada equation ni, apa yang kita boleh manipulate lagi? Tau dia. So kita tengok pada tau 1 hingga tau 3 yang sama. Lepas tu kita increasekan dia. Tengok apa trend dia. Alright? Okay, faham ke up till now? Sebenarnya dia guna pada basic equation sahaja. It's just that you kena know how to use it. Combine it according to the question lah. Okay? Are you okay before we proceed to assignment 1?
Okay, Doktor.
Okay, tak apa, jangan rasa down. Okay, it's normal kadang-kadang. At least you try to belajar something lah daripada answer scheme ni, and kita you try to buat betul-betul FA. Okay, so kita akan bincang betul-betul nanti tutorial 7. Khamis ni I akan tunjuk macam kalau boleh you try lah to sekolah FA. Saya percaya kalau awak betul-betul faham, jangan last minute study, you bolehlah jawab sebenarnya insyaAllah untuk FA. Okay, so you kena faham lah, CRE ni dia macam at max tau. You tahu equation, it's just that you kena tahu macam nak apply. Macam tu lah, macam nak relatekan dia. Alright, so basically sama je. You kena tu je lah, manipulate. Okay, alright, so for question 1, okay, so this is a decon process which involve gas phase. Okay, so dia dah bagi tahu this is a gas phase. Okay, alright, so an equal molar of HCl and O2 are fed to the reactor with total pressure of 4.7 atm. So dia dah bagi this is the P0. Okay, and T0, alright, as the reaction temperature. By taking HCl as a limiting reactant, okay, following experiment data we were recorded from constant batch reactor volume. Okay, so this is a constant batch reactor volume. Okay, baca line by line. Okay, so given the T and P, alright. Okay, so we have let's say this is A plus B is equal to C plus D. Okay, when it kalau ada limiting reactant means that you kena divide lah all this dengan 4. Okay, so you will have A plus with the 1 over 4B is equals to 1 over 2C plus with the 1 over 2D. Okay, alright. So basically kalau you tengok ni dia ada bagi P. Selalunya kalau kita tengok common one, you selalu familiar with T dengan CA0 kan, ataupun C. Okay, so sebenarnya basically dia akan use fundamental balik, which is ideal gas law punya ni lah equation. Okay, to get this concentration. Okay, sebab sekarang ni you kena determine what is the rate constant. Okay, using numerical. Okay, daripada sini of course information yang you kena ada value of a CA. Okay, so you kena tahulah what is CA. Letak lagi satu dalam sini. Okay, so CA here we have a mole, okay, over with the decimeter cube. Okay, so you can check lagi satu information. So how do you cari is by applying the ideal equation, which is CHCl is equal to PHCl over with the RT. Okay, basically you can get CN0 sebab dia dah bagi dah P0 dengan ni. Okay, and dia dah kata equimolar of HCl, means that equimolar means yang masuk YN0, alright, akan sama dengan YB0, which is dia akan jadi 0.5 lah. Sebab equal, so 0.5 plus 0.5 dia akan equal to 1. Okay, so CN0 is equals to YN0 P0 over dengan RT0. Okay, so you will get 0.05 mole over decimeter cube. Okay, so daripada sinilah you akan guna untuk dapatkan what is Ca. Okay. Okay, so daripada sini you akan dapat this is 0.05. This one is 0.00379. Lepas tu 0.0306, 0.0255, 0.0221, and so on. This one is 0.0171, and this one is 0.0195. Okay, so you kena construct lah what is the stoichiometric table dulu. So stoichiometric table biasalah you buat species semua tu. We have a HCl, we have oxygen, we have a Cl2, and we have a H2O. Okay, so dia dah kata this is batch reactor volume, so you boleh start dengan initial number of mole. Okay, so kita just buat A, B, C and D. So this one is initial. Okay, so this one is species, this one is symbol. Okay, this one is initial. Okay, this one is change, and this one is remaining lah. Okay, so start with the negative NA0 X, and then we have to change NA0, and then we have NB0, and we have NC0, and we have ND0. Okay. Kalau you nak buat letak theta, in term of theta pun boleh ikut pada you. So this one is NA0 X minus 1 over F, n 1 over 4 plus with the 1 over 2 NA0 X, and then we have plus half NA0 X. Okay, so remaining ni you just campurkan dia lah, you akan dapat lah. Okay, so you boleh tukarkan dia pada concentration jugalah. Kalau concentration sekarang V is equal to V0. Okay, so contohnya we have this one is equal to Na is equal to Na0 minus with the Na0 X. Okay, so nak dapatkan C, sekarang C is equal to N over V. Okay, so bahagikanlah this one with the V0, so you akan dapat Ca equal to Ca0 minus with the Ca0x. Okay, so daripada situlah. Alright. So yang ni you tahu kan dapat daripada tau Ca0 minus Ca over dengan Ca0. Okay, so you dapatlah Ca. Okay, so daripada situ boleh dapat semua tu, and you kena construct lah guna differential method. Okay, differentiatekan dia. So let's say we have kita akan differentiatekan in term of start daripada Ra is equal to KCa. Alright, to the power of number kita tak tahu apa dia. Okay, so we have a dCa over dt is equal to negative KCa. Okay, so daripada sini buatlah ln negative dCa over dt is equal to ln K plus with the alpha ln Ca. Okay, so you can construct plotkan dia, plot ln negative dCa over dt versus with the ln Ca. Okay, so your alpha you will get around 2 and K is around 0.127 to the cube mole over mean. Okay, so that's will be the answer lah. Okay, faham ke? So far? Risau pula I senyap-senyap ni. Faham ke tak ke I punya internet ni ada problem?
Tak berapa faham
Doktor
je.
K berapa?
Oh, okay, alright. Kalau you nak tanya, you boleh tanya je terus tau. Okay, jangan segan-segan. Okay, kita ni learning process. So kalau apa-apa yang you tak faham, you tanya direct je. Boleh. Okay, so kita go to question 2. Okay, question 2 nanti kita break lah sebelum tu. Okay, lepas question 2 kita break sekejap. Alright, so question 2 is for the gas phase reaction. Okay, so sekarang ni gas phase reaction. Okay, sebab disebabkan assignment 1 I banyak test you pasal gas. Okay, that's why MTA semua pada pasal liquid saja. Okay, right, so seimbang lah kat situ. Okay, then we have C2H4 plus C4H6 equal to C6H10, which is carried out isothermally in a constant volume batch reactor. The rate law of reaction is given. Okay, so dia dah bagi dah rate of reaction. Okay, so this will represent the K. Okay, and this will represent the this is K naught lah. Okay, so this is the E. Okay, and R is given juga, tak perlu cari. Okay, rate of this appearance of C2H4 is 8 times 10 to the power negative 3 mole per liter second ni. Okay, so this one is the, ingat, rate of disappearance means that this is the R. Okay, negative R C2H4. Okay, so this is the given, the value given. Okay, so find the temperature and pressure would be to achieve 57.6 conversion. So dia nak tahu kalau kat X 57.6 apakah temperature and pressure dia. Alright, please note the reactor initially are in equimolar ratio and time required to achieve is given for minute. Okay, so daripada situ you kena back to basic lah, which look back at the red law. Okay, so daripada sini, okay, you kena tahulah T ni yang dah differentiatekan dia in term of time is equal to N. Okay, C2H4 naught, alright, V naught, alright, Fx naught, dx negative RC2H4. Okay, ni V besar, sorry, V besar. Okay, ni basic dia lah, daripada negative RA is equal to 1 over V dN over dt. Okay, so just integratekan dia. Okay, so bila you integratekan, you dapat di sini lah. So daripada situ, of course this one kita boleh jadikan dia, this is a C2H4 naught. Okay, at time 0, alright, times with the, okay, ni dah integrate, dia akan dapat X over negative R C2 C2H4. Okay, so X dah given 57.6 to 0. Okay, so CN0, okay, yang this one kita kena carilah dulu. Okay, so daripada situ you akan dapat C2H4 naught is equals to 3.33 mole per liter. Okay, you tak boleh dapat direct daripada PV and RT sebab dia tak given pun what is the value of P dengan T. Okay, that's why you kena start dengan sini dulu. Okay, so daripada situ get the negative RA. Okay, so negative RA, okay, is equal to K C2H4. Okay, C2H4 dengan C6 C4H6. C4H6. Okay, so masukkan balik. Okay, so K C2H4, alright, untuk initial, alright, dia dah given, which is around 3.33 mana jap. Sekejap saya tulis. Okay, jap, ni 3 C2H4. Okay, sekejap, ni saya buat lagi elok lah. Mana pemadam dia. Okay, sekejap, saya tulis kat sini lah. So negative RA Okay, dekat not is equal to K, C, C2H4, and then C, C4H6. Okay, and then we have so K, K, C, C2H4, alright, at 0 time initial, sebab dia bagi dalam initial. Okay, 1 minus X daripada sini. Okay, nanti saya terangkanlah dari sini. C2H4. Sebab dia banyak sangat apa subscript semua ni. So, saya macam agak C C4H6 not C2H minus X. Okay, so daripada sini sebenarnya ini dapat daripada stoichiometry lah. Apa nama benda lah tu, stoichiometry yang dia buatlah table untuk dapatkan C untuk B ni. Okay, so A plus B is equal to C. Dia arrangekan dia balik. Okay, so masukkan balik. So K kita tak tahu sebab sekarang ni K yang dia beri ni adalah K naught. Alright, so this one actually is dalam bentuk K naught. Okay, so daripada situ you akan dapat what is the K untuk yang asal ni lah. Okay, untuk bukan dekat K naught. Okay, so daripada sini we have a negative RA is equals to negative RA kita dah diberi which is 8 times with the 10 to the power of negative 3. K kita tak tahu. Okay, sebab this is K naught ya. Sebab kalau you ingat dekat Arrhenius equation, this one would be K is equal to K naught exponent, alright, if negative A over T. Okay, so this is K naught yang dia beri. So kita tak ada K. Okay, so you can cari nilai K. So rearrangekan dia. Okay, so this one is 3.33 yang you dapat lah tadi, 3.33. Alright, so this one is 0.57. Okay, so this one equimolar. So equimolar concentration dia akan sama. Okay, sebab equimolar is YA0 is equal to YB0. Okay, so automatically CA0 akan equals to CB0 sebab T dengan P dia adalah dekat operating condition yang sama. Okay, so this one would be equal to 1. Okay, tak payah cari yang ni lah, yang awal untuk CB0 tu. Okay, so this one replace juga, this is 3.33. Okay, replace X dengan 0.576. So you akan dapat K is equals to 4.013 times 10 to the power over mole per second. Okay, so you dapat yang nilai ni, you can get what is P dengan T lah. Alright, so nak dapatkan T using this one, nak dapatkan T adalah tengok pada Arrhenius equation. Sebab T is equals to K is equals to A E negative E over RT. Okay, so this is around K dah diberi here, just put here K. Alright, and then this one is A ataupun ni lah, A besar atau K naught. Okay, E masukkan dalam ni. Okay, R yang kita dapat, T ni yang kita nak tahu apa dia. So automatically kita dapat T is equal to 608.4 K. Okay, faham? Faham ya? Sini K, this one A ni ataupun K naught. Okay, K naught ni yang ni lah, guna directly here. Okay, so EA replace 115,000 and then R ni replace kat sini, T ni yang kita nak cari. Okay, and then dapatlah, dapat nilai T dia, this one. Okay, and then another one, we have a P naught. Macam mana dapat pula P naught? Okay, so P naught is equal to N naught RT. Okay, so we have P naught is equal to C naught RT sebab N over V naught is equal to C naught. Okay, so disebabkan dia equimolar means that yang saya cakap YA naught is equal to YB naught yang masuk sama, so dia 0.5, this one is 0.5. Okay, alright, so daripada situ keluarkan what is C naught. C naught, remember C naught Alright, C naught is C total naught tau. C total naught is equal to remember ni topik number 2 atau 3 tak ingat. Okay, so equal to C A naught over Y A naught. Okay, remember kalau kita tahu C A naught, Y A naught is equal to fraction C A naught over C T naught. Okay, so C T naught ni sebenarnya mewakili daripada this one, which is P naught is equals to C T naught R T naught. Okay, so masukkan balik. Alright, C A naught ni adalah the one that you dapat ni lah. This one is C A naught. Okay, so C A naught is 3.33 and Y A naught is 0.5. Okay, and then R2 replace dengan yang ni. Alright, T kita dah dapat tadi, which is 608. Alright, so to get the P naught is equal to 33687.8 kPa. Okay, so that would be the answer lah. Okay, T nanti masuk balik kat sini, dapat balik. Okay, so far faham ke? Risau pula I all. Faham ke? Sebenarnya diguna macam back to ideal law punya equation, erroneous equation dengan red law. Okay, itu sahaja sebenarnya. Cuma you just rearrange dan definekan dia balik in term of nak cari T, P, temperature, time, macam tu lah. Alright? Okay? So nak need a break sekejap ke? 3 minutes break?
Boleh.
Okay, 3 minutes. Confirm ke kita punya final assessment 17 hari bulan? Sebab saya tak dapat lagi email ke apa.
Tak sure, Doktor.
Tak sure. Okay, tak apa.
Kat ni saya check 17 ada.
Apa? Tak dengar?
Setakat ni saya check final untuk subjek ni 17 bulan.
Oh, 17 bulan pagi 9 hingga 12 saya.
Ya, betul. 9 hingga 12.
Alright. Macam biasa nanti kita akan buat dalam Microsoft Teams lah. Macam MTA jugalah. Okay, hopefully I doakan sangatlah supaya insyaAllah semua student score lah untuk ni final assessment. Okay. So kalau apa-apa tak faham, boleh je tanya saya, okay? Jangan segan lah, okay? Sebab kita pun ialah sama-sama belajar. Alright, kadang-kadang saya pun tak ingat apa yang tiba you tanya, saya tak ingat. So, I kena tengok balik. So, macam you pun sebenarnya contribute to saya punya knowledge juga lah. Macam tu lah, okay? So, sama-sama lah kita. Okay, boleh sambung ke? Sebab you all lepas ni dia dah pukul 12 kan nak break. Okay, saya sambung ya.
Boleh doktor.
Okay, alright. Okay, so question number 3 ni, by using the temperature and pressure obtained in part A, okay, so okay, kalau misalnya you tak dapat pun temperature dan pressure yang betul, tapi I consider lah kalau ada jalan kira untuk yang soalan ni, okay. Alright, with the gases mixture feed of 75%, C2H4 and C4H6 25%. Okay, so dia dah bagi dah nilai baru untuk YA0 dengan YB0. Okay, this is YA0 and this is YB0. Okay, for variable volume of flow system to achieve higher conversion of C2H4 up to 85% for 10 minutes. Okay, so dia sekarang ni target dia lah X adalah 0.85. Okay, untuk time 10 minit. Okay, reactor consists of 200 tube. Okay, sebenarnya benda ni pun saya dah bagi dekat tutorial sebenarnya, cuma dia basic sikit lah. Tu je. Okay, ingat kan kita ada kira tube semua tu, remember? Alright, so reactor consists of 200 tubes with inner diameter of 1.5 inch. Okay, so dia dah bagi, and dia adalah persamaan 200 and diameter dia adalah 1.5 inch. Reaction is second order with respect to C2H4. Prepare a detailed design calculation, estimate the production rate of C6H10, state all the assumption made. Right? If the result from this reaction is flow by any chance, determine the reaction time at the conversion of 85%. Okay, so you kena carilah kira sebenarnya apakah production rate dia, which is what is the FC dia. Okay, so you kena dapat sebenarnya apa dia FC. Okay, so first start dengan mole of balance. Okay, this is PFR. So PFR, mole balance dia dx over dv is equal to negative RA over FA naught. Okay, so you tukarlah, diameter inch ni, you tukarlah 1.5 inch ni, I kira around 0.0381 meter. Right. Okay, so second, start dengan rate law dia. Okay, so rate law, okay, kalau dia stated dalam equation tu ikut pada equation. Kalau dia tak stated, dia ikut pada elementary. Okay, so it's equal to negative RA is equal to KCA kuasa 2. Alright, so stoichiometry pula. Okay, disebabkan this one, remember dia adalah variable volume. Dia dah bagi tahu variable means that dia takkan sama macam ni. Alright, so dia akan jadi V is equal to V naught. Remember, this is gas. So dia tekan 1 plus epsilon X. Okay, alright. So daripada situ, buat stoichiometry lah, one by one. Okay, for example, I terus ni lah nak cepat. So we have a FA is equals to, kenapa? Macam ni nak back you all? Escape ke? Okay. So FA, okay, is equal to FA not 1 minus X. Okay, so we have FA V is equal to, alright, remember, sekarang V is equal to V naught. So dia akan automatically V naught, alright, 1 plus epsilon X. Okay, and this one remain lah 1 minus X. Okay, so this one this one kita boleh jadi concentration CA0 1 minus X 1 plus epsilon X. Okay, so on. Okay, so you can cari untuk FA, FB dengan FC lah. Okay, so dari sini kita carilah what is del. Alright, sebab sekarang ni epsilon is equal to YA0 times with the del. Okay, so daripada situ del is equal to 1 minus 1 minus 1. Okay, ikut pada stoichiometry tu lah, A plus B is equal to C. Okay, so you akan dapat minus 1 here. And this one is around 0.75 lah. Sebab YA0 sekarang ni 0.75 times with the negative 1, so dapat negative 0.75. Okay. So sekarang ni you kena dapatkanlah what is the volume, okay, for single tube. Okay, sebenarnya dia punya cara lebih kurang macam yang tutorial kita buat tu lah. Cuma hari tu saya bagi total semua. Sekarang ni you kena cari satu-satu lah. For volume for single tube, kita ada V is equal to pi r squared H. Okay, so this one bagi 2 lah. Okay, nak dapatkan R. Okay, so you akan dapat around 1.146 then negative 3 M3. Okay, and then so for 200 tubes, makanya you can darab lah. Saya je table lah, tubes. Okay, so V is equals to 1.146 times 10 to the power of negative 3 M kuasa 3 darab dengan 200 tubes. Okay. So daripada sini you akan dapat, saya convert dekat liter, jadilah around, ikut pada unit, still remain M3 pun boleh, liter pun boleh, ikut pada kesesuaian lah. Okay, so daripada sini I dapat around 229.22 liter. Okay, so this volume untuk 200 tubes. Okay, so sekarang ni kita kena tahu what is CA0. Okay, sebab CA0 dah berbeza, CT0 pun dah berbeza. Okay, so daripada situ you kena calculate lah. We have a PV is equals to nRT. Okay, daripada situ sebab apa kita kena start daripada sini? Sebab kita nak kira what is CA0. Alright, so kenapa CA0 ni penting? Sebab CA0 ni kita nak kira what is the kita nak compare, alright, sama ada betul ke tak reaction time tu achieve 10 minit ni untuk reaction 85%. Okay, so of course kita kena determine what is tau. Okay, sebab you kena prove kan betul ke 10 minit ni sesuai untuk 85%. Okay, so that's why you kena recalculate tau tu. Okay, so daripada situ tau kan is equals to V over V0. Okay, so V ni akan relate dengan tau. Okay, sorry, tau ni akan relate dengan V. V ni akan relate dengan CA0. Okay, sebab kalau you tengok V ni here, mana I punya ni? Ni, dia akan relate dengan RA. Okay, so RA ni akan, kalau you keluarkan, dia akan jadi KCA kuasa 2. Okay, which is equal to, keluarkan dari sini lah. This is KCA0, okay, kuasa 2, 1 minus X kuasa 2, 1 plus epsilon X kuasa 2. Okay, so benda ni relate, that's why dia kena cari CA0. Okay, so daripada situ, this is a mixture in a gas phase total. Okay, so yang you dapat ni sebenarnya adalah total tau. Okay, bukan single. Okay, so what you need to calculate is PV is equal to nRT. Okay, so remember N over V ni sekarang mewakili untuk total. Okay, so daripada situ masukkan balik. Okay, we don't have the value of number of moles, tapi you boleh dapat sebab you dah ada semua information. Macam ni kita ada V total daripada sini. Okay, so we have P yang tadi 336 from previous apa nama benda previous questions. VT adalah total dia. Remember this is total tau, sebab gas yang dalam PFR tu yang mixture, walaupun dalamnya ada banyak tube, gas yang dalam tu mewakili semua tube. Okay, alright, dalam satu PFR tu akan ada 200 tubes, which is reaction tu berlaku untuk gas mixture. Okay, alright, so this one times with the 229.22 daripada sini liter. okay, is equals to MT, total tak tahu, 8.314 times with the 608.4 temperature. Okay, so and total is around 1526.16 mol. Okay, daripada situ you akan dapat what is CT. CT is equal to NT over V. Alright, so we total so NT 1526.16 mol over liter 229.22 liter. Okay, so jawapannya adalah around 6.658 right mol per liter. Okay, so daripada situ you akan dapat CA0 lah. CA0 is equal to 0.75 times V. Okay, ni YA0 times with the CT0, you akan dapat lah CA0. Alright, 6.658 mol per liter. Okay, so you dapat lah what is CA0 here. Okay, so bila you dapat dah benda ni, you boleh dapat dah masukkan balik dekat sini. Okay, so pergi next one. Okay, so remember we have a dx over dv. Okay, so ini macam sebenarnya division jugalah, elok juga. Okay, untuk you fokus. At least ni bolehlah juga untuk guna untuk finance sebenarnya. Kita revise balik kan previous topic. Okay, and then we have a FA0 dx over negative RA. Masukkan balik what is RA. Okay, so FA0 is equals to F dx over 1 minus x kuasa 2. Okay, 1 plus epsilon x kuasa 2 CA0 2 dx. Okay, yang ni kalau susah tu you guna je lah online integration ke apa ke. Okay, ataupun dalam ni sebenarnya ada dalam buku appendix. Okay, you will get V is equal to V0 over CA0 K. Alright, 2 epsilon. Ni lah dia sebenarnya panjang macam ni lah. Plus epsilon 2x plus 1 plus epsilon. Okay, alright. Okay, so daripada sini dapatkan what is V0. Okay, sebab kita dah tahu V apa, CA0 apa. Okay, K pun dah diberi. Okay, epsilon kita dah cari, so kita boleh dapat V0. Okay, V0 ni dalam ni, saya rasa ada tersalah kira sikit tapi tak apalah. Ini, alright, yang penting saya tunjukkan jalan dulu lah. Okay, so and then we have tau. Okay, sebab kita nak tahu what is tau, nak proof lah adakah ada 10 minit untuk 85%. Okay, conversion. So it's equal to V0. Okay, you akan dapat around 7.824. Okay, so tak proven lah. Sebab dia katakan 10 minit untuk ni kan. Alright, so daripada situ you kira lah what is the FC. Okay, sebab nak tahu what is the new capacity. Okay, FC is equal to FA0 times with the X. Okay, so FA0 dapat dari mana? FA0 dapat daripada CA0 over V0. Okay. Alright, V0 ni dapat sebelum ni lah dengan ni. Okay, daripada situ you akan dapatlah around 0.164. Okay, so itu je lah. Faham ke? Up to this point? Okay.
Okay, doktor.
Okay, sebenarnya itulah dia guna equation yang sama, cuma dia punya arrangement dia, sequence tu lah dia akan berlainan steps dia ikut pada soalan. Okay, mana value yang you perlu cari and so on. Okay, so that one lah. Okay, so this one yang ni terpulang pada you kalau you tapi sebenarnya basic konsep dia macam ni lah. Basic konsep dia large CSTR dia akan selalunya bagi lower X, alright, and small CSTR dia akan lebih X. Okay, so kalau kita ada dua, okay, ni refresh balik lah. Okay, so kita ada V1 dengan V2. Okay, ni kalau MFR tau kalau CSTR. Okay, so we have FA0. Okay, so kita ada FA1, FA0. Okay, and then kita ada X1 and then we have X2 here. Okay, so daripada sini sebenarnya adalah tau 1 over C0 is over X1 over negative R1. Okay, ini I dah rearrange lah. Kita punya equation. Okay, so basically kalau nak tengok, okay, remember dia adalah kalau CSTR dia adalah curve mewakili rectangle, dia bukan area under the curve. Okay, area under the curve adalah untuk PFR. Okay, so kalau let's say X1 awak rendah, okay, tapi XU tinggi. Okay, kalau you tengok, kalau X1 rendah, okay, compare dengan, okay, I buat dua graph. Compare dengan X1 rendah, X1 tinggi, X2 rendah, okay. Kalau you tengok ni, volume mana lagi tinggi? Volume, kalau untuk first volume, dekat X1 tinggi ke? Untuk number 1 ke number 2?
Number 1 kot.
Kalau kita tengok, kalau volume number 1, okay, dia akan jadi small CS, dia akan macam cakap, okay, katakan this one, okay, kalau you tengok, kalau dekat X1 lagi kecil, okay, kecil, V dekat 1 akan small. Okay, kalau kat sini pula X1 tinggi, V1 akan tinggi. Okay, tapi at the end sebenarnya dia akan reach X2 yang sama. Okay, so X2 dia selalunya takkan berubah lah. So sebenarnya sekarang ni akan jadi isu lah sama ada awak nak, kalau dari segi economical, okay, adakah you nak larger V ataupun smaller V. Okay, lagi satu, economical, you nak higher X ataupun lower X. Okay, so benda ni lah you akan kena discuss. Okay, so contohnya macam ni, kita akan dapat volume 1 akan lebih daripada V2, V1 akan kurang daripada V2. Okay, so kalau kita nak maximizekan dia sebenarnya, kita kena, kalau boleh, kalau you looking at the economical, you nak lowerkan volume, alright, sebab you tak nak ada cap, what do you call it, apa pun nama Allah tu, macam kita nak, apa nama dia, yang cost untuk buat something, okay, kalau you tak nak spend lot of course you kena go for the X1 yang rendah lah untuk first reactor. Sebenarnya macam tu lah, dia tak ada macam fix punya jawapan, tapi as long kalau you bagi tu adalah relevant, boleh dia dapat markah. Okay, alright. So untuk number of itu kat sini lah, salah satunya adalah the optimum size ratio for two mixed flow reactor in series is found in general to be dependent on the kinetics of direction and juga conversion. Okay. Okay, so selalunya kita perlukan number of series ni in order to achieve higher conversion lah. Okay, for example, kalau kita ada satu reactor je, dia boleh achieve dekat ada one point je. Katakan this one is 0.3 and this one 0.7. So of course you need two reactors in order increasekan dia lagi ke 0.9. Macam tu lah. Okay, so nanti kalau you buat ayat apa-apa yang boleh relevan ni, I bagi je markah. Okay. Alright. Okay. Alright. So question number 5 ni. Kenapa number 5? Okay, number 4 ni pula. Okay, number 4 ni sebenarnya you kena buat graph lah. Okay, if two reactors keen to be isoesteem, propose the best reactor arrangement for the same conversion in A that give optimum condition, justify your answer. Kenapa terus ni? Question 3. Oh, I lupa nak letak 4A lah. Ya Allah. Okay. So, sekejap. Okay. Sorry ya, saya tertinggal lah nak letak 4A sebenarnya. Okay, so number A ni, alright, patutlah je pelik. The given tau CA0 dengan CA, alright, and it is irreversible isomerization of N-pentane, alright, in a MFR. Using data from table 2 suggests the best flow reactor for 85 conversion when the feed rate consists of 100 mole per decimeter cube of N-pentane. Justify your answer. Okay, so benda yang you perlu buat. Okay, sekarang ni you ada, okay, kita define as negative RA is equal to CA0 minus CA over tau. Okay, and we have another one, V is equal to FA0 X over negative RA, okay, which equal to CA0 V0 X over negative RA. Okay, so V over V0 is equals to tau is equal to CA0 X over negative RA. Okay, so sebenarnya inilah equation yang related. Okay, so sekarang ni kita nak plotkan graph dia in order to get the volume. Okay, so we have a T here. Okay, graph dia, and then we have a CA0. Okay, and then we have a CA. Okay, so sekarang ni kita nak dapatkan graph versus, okay, sama ada you nak buat FA0 over negative RA ataupun you boleh buat over negative RA juga versus feeder X. Okay, sebab kita nak cari volume. Okay, so guna apa yang ada kat sini, okay, in order for you to dapat plot ni. Okay, so daripada situ you kena derive apa-apa benda. Okay, guna je information. Kenapa saya relatekan first ni dulu? Sebab tengok, sebab dalam information ada CA0, CA dengan tau ataupun T. So apa yang relate adalah daripada equation asal ni lah. Just manipulate in order for you to dapat benda ni. So automatically sebenarnya you boleh dapat what is RA. Okay, so negative RA is equal to CA0 minus CA over tau. Okay, so automatically kita boleh kira what is 1 over RA. Okay, alright. So daripada sini kita boleh tahulah what is CA. Okay, so untuk 0.85, CA untuk 0.85 adalah CA0 1 minus X. Okay, so CA0 dia dah bagi 100 mole over decimeter cube. Okay, 1 minus speed dia 0.85. So kita nak tengok dulu 85% berapa. So CA dia adalah mole decimeter cube. Alright, so sekarang ni you kena tengok mana satu okey, CSTR ataupun PFR. Okay, so you can cari tau lah in term of tau. Okay, so daripada situ remember kalau CSTR adalah area under the area of the rectangle, kalau PFR adalah area under the curve. Okay, so you construct. Alright, kalau untuk TCSR you boleh guna directly, tak ada masalah sebab dia adalah algebraic form. Okay, so you akan construct sini, kalau you perasan dia tak ada dekat 85. Okay, so you just budget lah berapa. Okay, so it's around 0.1325 100 minus 50. Okay, sebab this is for X, so 11.2625 second. Okay, ni saya kena bagikan. Okay, 200 150 40. So this one is 7.1. So banyak. So far you all catch up ke tak ni? Risau pula saya just semua cakap ni kalau
Berapa sangat?
aduh tak berapa. Okey, kat part mana yang tak berapa?
Saya pun tak tahu lah macam mana.
Aduh, sebab adakah terlalu banyak sangat information hari ni sampai you dah jadi saturated?
Dia macam ni doktor, dia kena buka-buka lagi buku-buku tu. I mean slide awal-awal. Macam tu baru dia nampak sikit.
Ya, betul. Sebenarnya benda ni memang kena buka slide. Kan saya rasa kan lebih baik kan bila awak nak study ni, awak buat mind map. Mind map yang berkaitan dengan semua equation yang terlibat. Okey, sebab bila awak buat mind map, awak boleh terus refer satu page tu, semua equation ada. Macam dulu saya pernah kerja, nak bercerita lah. Tak apalah, yang lain ni saya record lah, senang. Sebab saya rasa dia terlalu banyak information lah. Which is question 4 and 5 ni saya record. Okey ke tak?
Okey, boleh madam.
Okey. Sebenarnya kan saya nak suggest lah bila awak belajar CRE ni, okey, mind map tu memang penting. Sebab setiap, kalau you perasan, setiap topik ni dia akan berkait rapat tau. Okey, tapi sebenarnya benda ni adalah basic equation saja. So you kena relate topik 1 ni dengan topik 2. Okey, topik 3, topik 4, topik 5, okey, and then pecahkan dia lagi, kalau gas phase macam mana, kalau liquid phase macam mana, okey. So bila you dapat the whole picture, mind map tu, you senang nak relatekan dia. Okey, rather than you separatekan notes tu satu-satu. Bagi I lah, okey, I senang faham macam tu lah. Okey, lepas tu sebab dulu memang dulu sebelum I jadi lecturer, I memang bekerja lah as engineer. So pernah merasai bekerja dekat company Jepun juga. Memang kita panggil fishbone. Memang digalakkan untuk buat mind map untuk senang nampak the whole picture. Okay, so saya suggest you buat tu, baru you boleh senang nampak lah. And then you kena practice exercise tu, bukan setakat kena tahu je equation, kena macam mahir nak guna mana satu. Tu penting. Try buat steps dia dulu. Okay, mula kena cari apa? Maybe cari RA. Okay, RA ni dia relate dengan apa? Maybe dalam equation tak ada K. So macam nak cari K? Maybe K kita relate dengan erroneous. Macam tu lah. Itu yang saya boleh suggest lah. Okay, ada lagi tak nak tanya benda lain? Sebab saya rasa pun sebab terlalu banyak information kot, ibu macam yelah agak mix up semua tu lah. Ada apa-apa ke lagi nak okey, apalah untuk last session minggu hari Khamis ni, apa yang you nak sama-sama I revise, topik mana, nanti you comes out lah hari Khamis nanti beritahu I. Maybe you nak further clarification atau nak I explain balik ke topik, maybe topik 4 you ada benda part yang you tak faham ke, nanti you bagi tahu lah masa waktu tutorial 7, boleh ke? Okay, so you tengok balik dulu mana yang you tak faham, and then kita discuss balik dekat tutorial 7, okay? Yang ni lagi 2 ni I akan record lah. Okay, so keep dah better. Okay, so stop sharing. Okay. Alright, okay. Okay, so sekarang pukul berapa? 1:38. Okay, so I'm hoping that you do the tutorial 7 and try kita discuss apa yang you nak lebih faham Khamis ni. Itu sajalah kot. Itu je lah.
Madam nak tanya.
Ya, Amir.
Kalau final exam nanti dia keluar semua topik ke?
Dia sebenarnya dia question number 2 dengan 3 tu dia nombor 2 tu dia adalah multiple reaction. Nombor 3 tu non-isothermal. Nombor 1 tu dia adalah teori pada fundamental lah. So nombor 2 tu, question 2 tu multiple reaction, kalau you perasan dia berkait balik dengan multiple reactors. Okay, so basically you kena faham lah dia punya semua topik lah sebenarnya. Tapi fokus dia pada macam question tu adalah multiple reaction. So tengok multiple reaction dia more pada apa? Tengok selectivity, tengok yield. So you tekan kat situ lah. macam nak isothermal dia still relate dengan topik 4 which is you kena ada algorithm step semua tapi berlainan dia pada energy balance. So you fokus fahamkan pada energy balance. Macam itulah maksud dia. Okey, faham ke maksud saya?
Faham madam, maksudnya kena study semua lah. Pada
Study semua tapi
itu tu kena kuat lah.
tapi fokus lebih tu pada yang kena fahamkan lebih sangat-sangat tu yang untuk tackle tu lah energy balance, selectivity, causing reaction pula RA net dia macam mana, parallel, series, lepas tu irreversible. Sebab irreversible dengan reversible pun dia ada kaitkan dengan chapter 7, topik 7. Sebab tu dapat KE macam mana, K kecil macam mana, macam tu lah. Macam nak guna energy balance semua tu. Okay? Alright ke?
Okay madam.
Tak apa, nanti kita akan try to recall balik lah dekat Khamis ni. Okay, setiap topik tu. Okay, saya rasa itu sahajalah. Nanti saya recall lah yang the remaining. Okay, tapi tak janji hari ni, maybe esok lah kot saya bagi. Esok atau Khamis. Alright, itu sahaja semua. Kita end our class with tasbih kifarah and surah tu'as. Okay, alright, okay, itu sahaja ya. Selamat berlunch time lah. Okay, Assalamualaikum. Terima kasih.
Salam. Thank you madam.
Assalamualaikum.